Welcome back. Today we're going to be talking about VLANs, virtual local area networks. The goals for today are to understand what a VLAN is. We're going to be talking about access port versus trunk ports, and we're going to be configuring VLANs via Cisco Packet Tracer. So we'll do some labbing on Cisco Packet Tracer with VLANs. So what is a VLAN? A VLAN is a network configuration that segments devices into separate broadcast domains within the same physical infrastructure. VLAN stands for Virtual Local Area Network. And the key idea with VLANs is VLANs allow you to segment a single physical network into multiple isolated networks. How they work: VLANs are created on a switch. Each VLAN is assigned a unique ID, for example, 10, 20, 30. And then ports are assigned to the VLANs. So each switch port is placed into a specific VLAN. Devices connect to that port to become part of that VLAN. Traffic will stay within the VLAN, so devices in the same VLAN can communicate directly, and traffic is isolated from other VLANs. Broadcast domains are separated, so each VLAN has its own broadcast domain. Broadcast traffic does not cross into other VLANs. So communication is happening just between each VLAN, right? So VLAN 10, VLAN 20, VLAN 30, they have their own communication. So communication between VLANs, if VLAN 10 wanted to communicate with devices in VLAN 20 or VLAN 30, then it would require routing. So it would require either a router or a layer 3 switch, and this is what is referred to as inter VLAN routing. So communication between two VLANs. So why do you want to use VLANs? So VLANs help with improving security. So it keeps sensitive data separated. It limits who can access certain parts of the network. It reduces network traffic, so broadcast traffic stays within each VLAN. It improves overall network performance. It also allows for better organization. You can group devices by department, role, or function. It makes the network easier to manage. It also allows for flexibility, so devices can be moved or reassigned without changing physical wiring. And it's easier to scale as the network grows. And also control and policy enforcement. So you can apply different rules to different groups, for example, access restrictions, bandwidth limits. So this is an example of VLAN, right? You have a switch and we have a couple of PCs. Two PCs here are within VLAN 10 and the PCs here are within VLAN 20. And they're part of the same physical infrastructure, right? All these four PCs belong to the switch, but they're logically segmented between these VLANs. So VLAN tagging. VLAN tagging is a method that's used to identify which VLAN a data frame belongs to as it travels across the network. So it's a small 4-byte tag that is added to each Ethernet frame to identify its VLAN ID and keep track of which VLAN the traffic belongs to. So tag versus untagged traffic. Tagged traffic contains a VLAN ID inside the frame, used when traffic travels between switches. It's a single physical connection. A single physical connection can carry traffic for several different VLANs at the same time using tagging to keep the traffic separate. So, you can carry traffic of VLAN 10, 20, 30 within the same. And then untagged traffic, so it does not contain a VLAN ID. It's used when traffic goes to end devices, for example, PCs, printers, and devices are unaware of the VLANs. Now let's talk about access ports. So an access port is a switch port that connects to a single device and is assigned to only one VLAN. Each access port is manually assigned to one VLAN. Any device connected to that port automatically becomes part of that VLAN. Commonly used for end devices like PCs, printers, and phones. Untagged traffic, access ports send and receive untagged frames. So trunk ports. Trunk port is a switch port that carries traffic for multiple VLANs between network devices. So unlike access ports, trunk ports can carry traffic for multiple VLANs, and it supports multiple VLANs on a single link. VLANs are identified using tagging. So unlike access ports, trunk ports do have tagging. And it's commonly used between switches or between a switch and a router. Tag traffic, so traffic is tagged with VLAN's IDs as it passes through the trunk, and it allows the receiving device to identify which VLAN each frame belongs to. So here's just a table of the difference between access port versus trunk port. So access port its purpose is to connect end devices, whereas trunk port, its purpose is to connect network devices. Number of VLANs, access port, one VLAN only, trunk port, multiple VLANs. Traffic type is untagged for access port. For trunk port, it's tagged, and it is assigned to a single VLAN for access ports. For trunk ports, can carry many VLANs over one link in its use case. So user device connections, for trunk port, it's switch to switch or switch to router links. And tagging, no VLAN tagging for access port, and trunk port VLAN tagging is used to identify traffic. So default VLAN. Default VLAN, VLAN 1 is the default native VLAN on most switches. It's used for untagged traffic on trunk ports. Untagged traffic, so frames sent without a VLAN tag are automatically assigned to the native VLAN. Security risk, VLAN 1 is often targeted in attacks, so it's a best practice to change the native VLAN to another unused VLAN. And then we talked about this earlier, but inter-VLAN communication. So inter-VLAN communication is the process of allowing devices in different VLANs to communicate with each other. Key idea is by default, VLANs are isolated, meaning devices in different VLANs can't communicate directly, right? They're segmented into their own network, so they're not allowed to talk to each other. When you have inter-VLAN communication, however, how it works is it enables communication between VLANs. So a layer 3 is required, such as a router, which you can do a router on a stick setup, or a layer 3 switch. So it'll use switch virtual interfaces. And these devices can receive traffic from one VLAN and route it to the correct destination VLAN and act as a bridge between separate networks. So this is just configuration for a VLAN. So to create the VLAN, you would go on the switch. You would type in VLAN and then whatever ID you want to give it. So VLANs have ID ranges from 1 to 4094. So anything you can't ID it, you can't give it a VLAN ID past that. So that's the range. And then you would name the VLAN, right? So you would name it whatever name you would like. And then you would add interface ports to the VLANs. For example, interface and then the interface port number. So it was a fast Ethernet 02. You would do that and then switch port mode access and switch port access and access. And then you would list the specific VLAN that you would want to access. And then you can go ahead and see the VLAN by doing show VLAN. So let's go ahead and jump into Cisco Packet Tracer. So here I already have a switch and I have 4 PCs. Right, I have PC 0, PC 1, PC 2, PC 3 with their respective IPs, right? So right now, as you can see, all these 4 PCs they're part of the same broadcast domain, right? They're part of the same broadcast domain. So this is currently their broadcast domain, right? And what I want to do is I want to go ahead and create VLANs, right? So I want to separate these devices. So I want this to be its own VLAN, and I want these 2 devices to be their own VLAN. Because technically right now they can communicate with each other, right? So PC 0 can ping PC 2, right? You can see they're able to ping each other, right? But when we set up the VLANs, as you're going to see, that communication is no longer allowed, right? Once you create VLANs, communication isn't allowed between 2 VLANs unless you have a layer 3 device involved. So this is going to be VLAN 20 and this will be VLAN 10. And what I want to go ahead and do is I'm going to go onto the switch. So let's go ahead and click enable, config terminal, and I want to create the VLAN, right? So we're going to create VLAN 10. I'll name this finance, and then I'll create VLAN 20, name that sales, and then we'll run the command do show VLAN, right? As you can see, we have the VLANs here. We have the default VLAN, right? The native VLAN. And then we have VLAN 10, VLAN 20, finance and sales. Now the next thing is we want to go ahead and add the ports, right? So I want to go ahead and add the ports here, fast Ethernet 01 and 02 to VLAN 10, and then fast Ethernet 03 and 04 to VLAN 20, right? So let's go back to the switch. So interface fast Ethernet 01. I'm going to do switch port mode access, and then I'm going to say switch port access VLAN 10. And then let's look at the VLAN. As you can see now, the interface has been added to that VLAN, right? So let's go ahead and do the next port. Next interface. So interface 02, fast Ethernet 02, switch port mode access, switch port access VLAN 10, right? Okay, and then let's go ahead and see now. You can see we have those there. Okay, now let's do the last VLAN. So let's go into those ports, fast Ethernet 03, switch port mode access, switch port access VLAN 20, right? Okay. Same thing, we'll run the command to look at the VLAN. As you can see, it's been added there. And the last thing is, the last port, we'll go ahead and add it. Switch port mode access, switch port access VLAN 20, right? As you can see now, we have, right, the ports 1 and 2 for these PCs in this VLAN, and then ports 3 and 4 on that VLAN, right? So next thing I also want to do is I want to make sure that we're going to use a range command to make sure that our ports are not shut down. So we'll do no shut, and we'll do 3, 4, no shut, to make sure that those ports are not up, and then we'll also go ahead and see so that all that stuff is up. And now what I want to show you is that I'm not going to be able to ping PC 0. It's not going to be able to ping that PC anymore. Right? Remember, we were getting that reply. Now, as you can see, we're getting requests timed out. And that's happening because we've now segmented the network, right? We've have this local area network, but it's now been segmented into separate virtual local area networks. So this is VLAN 10, and then this is VLAN 20. So you can see, failed, right? So we sent 4, received 4, lost 4, sorry. So we got ping failed. And essentially, as I mentioned, it's because we've now created VLANs, right? We've segmented this physical network into isolated networks, right? These 2 PCs here are in VLAN 10, and these 2 PCs here are in VLAN 20. If we want to communicate between these 2 VLANs, then that's when we would need a layer 3 device. But as of now, we're not able to have that communication, right? There's no inter VLAN communication that can take place because there's no layer 3 device. So we'll go ahead and end there. Thank you so much for watching. This was me just going over VLANs and showing you the configuration. So tune in for the next video. I'm going to be doing inter VLAN communication. We're going to be going over router on a stick, and also doing inter VLAN communication on a layer 3 switch.